In this video we look at compound interest problems. And the key to compound interest problems are they really are just a special case of exponential growth and decay word problems. And if you think about exponential growth and decay word problems, the key is this formula right here. Y is equal to A, 1 plus R to the T. Where A is the initial value, the initial amount you start with, and R is the growth rate, and T is how many time periods you have, and Y is where you end up with. So let's look at a simple problem where you start with $1,000 and the $1,000 grow at 6% per year, and you want to know how much money you have after 11 years. So you might think that if it's 11 years you get 6% per year, then it's 66%. But actually that's not true. It's more than that. And the reason is that after the first year you have not $1,000 but $1,000 plus 6%. I think that's $1,060. Now in the second year when it grows 6%, you get 6% not on the original $1,000 but on the $1,060 now. So what happens is you get interest on the interest. So that problem is pretty straightforward. It's Y is equal to 1,000, 1.06 to the T, where T is the number of years, so you just plug in 11 years, so it's Y is equal to 1,000, 1.06 to the 11, and we can just use a calculator to figure out what that is. And the way you do that is you go first 1.06 raised to the 11th, which is 1,000, about 1.898 times 1,000, and you get about $1,898.30. It turns out that this is just a simple growth problem, but here the key is this is compound interest. This is called a compound interest problem. Now that's a simple compound interest, a fairly simple compound interest. A slightly more complicated problem might be like this, but before we go on, let's identify some terms here. Here, A is often called the principal, because it's the principal, it's the amount that you start with. And R is the growth rate, but it's often called the interest rate or the return. And of course T is the time periods. Usually it's per year, but it doesn't have to be. And Y is what you end up with. So now let's look at a somewhat more complicated problem. So now let's say you put $5,000 in the bank and you get 4% interest per year. But interest is compounded monthly. And then you might want to know how much money you have after, let's say, 17 years. So here we're going to use a slightly different formula, and it's going to be Y is equal to A, 1 plus R divided by K, raised to the KT. And if you notice here in this problem, what's different is we actually have two different time periods. We get 4% interest per year, but it's compounded every month. So what that means is that after you go 1 month, they calculate your interest. And in the second month, you get your interest not on the $5,000, but on the interest that you got that first month. Then in the third month, you get interest not just on your $5,000, but on the interest that you have gained over 2 months. So that's compound interest as well, but here the key is there's two time periods. That's the key issue here. And here, let's go through this formula, and let's just make sure we understand all the terms. Here, A is your principal, or your initial amount. R is the interest rate, almost always per year. It doesn't have to be per year, but in every realistic problem, it's always going to be interest rate per year. And K will be the number of compounding periods per T. And that's actually a lot easier than it first sounds. I'm going to put per year, but it's not always per year, but it is in 99% of the cases. And then T is the number of time periods. In this case, the number of years. Now let's use this formula in order to solve this problem. Again, we have, let's go back to the original problem. We have $5,000, 4% interest per year, compounded monthly after 17 years. So that's just y is equal to A, 1 plus R over K, raised to the KT. So that's $5,000. 1 plus 0.04 divided by, now how many months are in a year? There's 12. And then 12 again times 17. And you plug that in a calculator. Now you have to be really careful, but let's make sure we understand what this is. $5,000 because that's how much money you start with. R is the interest rate per year, so that's 0.04. K is the number of compound periods per time period per year. So since it's compounded monthly, there's 12 months per year. And then it's just K times T. K is 12 and T is 17. So you can just plug this into your calculator. You have to be very careful here. Remember, you have to divide this first, so that's 0.04 divided by 12 plus 1. Now, I'm going to write this down, but it's actually better just to keep in your calculator. That's 1.00333 repeating. Then you're going to take 12 times 17. You're going to raise that. I'm going to go raise the parentheses 12 times 17. And I get 1.97. Times 5,000, and then I'm going to multiply it by 9,000 at last. Remember, that's 12 times 17, 5,000. And you get $9,858.23. And that's how you do a compound interest problem.